Hello, and welcome to another Orca3D video tutorial. This video is a crash course on using Orca3D in Grasshopper, from Grasshopper's basic concepts all the way to calculating hydrostatics. We'll start with a basic overview of Grasshopper itself. Grasshopper is built right into Rhino. You can access it through an icon on the standard toolbar, or by running the Grasshopper command in the command line. Grasshopper is Rhino3D's graphical programming interface. Your workspace is called the canvas. Functions and processes are represented by blocks on the canvas, called components. Components can do everything from modify and create geometry, manipulate data streams, or perform calculations. A component's input and output is handled by nodes on the component called parameters. Connecting two components is as easy as clicking and dragging from one component's outputs onto another component's inputs. Orca3D includes a growing list of Grasshopper components. Each component is a wrapper around existing Orca3D functionality. This means the workflow in the main Orca3D app often parallels the data flow across your Grasshopper canvas. For most users, the first step is to create their geometry, or import existing geometry from Rhino. Let's start with creating geometry right in Grasshopper with an Orca3D Hull Assistant. Go to the Orca3D tab in the Grasshopper ribbon. Go to the Hull Assistants category and pick one of the Orca3D Hull Assistants. Click and drag it onto your canvas. To adjust an Orca3D Grasshopper Hull Assistant, you can right-click on any of the input parameters and set a value directly. Or, from the Params tab, you can use a component like the number slider or panel to set values. The panel is a resizable text box on your canvas. You can type numerical values into it and connect it as an input to other components. If you change the value, the effects will flow on downstream. The number slider is an interactive component. As you drag the handle, the numerical value changes in real time. And again, the effects flow on downstream. With certain parameters, you may have to adjust the number slider's minimum and maximum values. Right-click the slider and select Values. Make sure to hit the check mark when you're done. All Grasshopper Hull Assistants have two output parameters: the collection of generated geometry and a description that lists the inputs, their values, and their units. You can connect the geometry parameter to other Grasshopper components, like an Orca3D Hydrostatics calculator component. If you have existing geometry in Rhino that you want to use in Grasshopper, linking Rhino and Grasshopper geometries is easy. Here in our Rhino document, we have a ship hull that's part of an Orca3D design. Let's use this in Grasshopper. Head to the Params tab, then to the Geometry category, and select the Geometry parameter. This will act as the placeholder for our hull geometry. To import our Rhino geometry, right-click on the Geometry component and select Set One or Set Multiple Geometries. Then, highlight all of the Rhino geometry that you'd like to import, and right-click when you're done. The red indicates geometry previewed from Grasshopper. It turns green when you select the component it belongs to. Let's walk through performing a basic hydrostatics analysis with Orca3D Grasshopper components. I'll assume you already have your geometry ready to go in Grasshopper. Just like in the main Orca3D app, the next step is to define a condition. In the Orca3D tab of the Grasshopper ribbon, open up the Hydrostatics category. There, you'll find a number of components that can generate input conditions for our hydrostatics calculation. We'll use the Sink Trim Heel input condition generator. Next, we'll head to the Params tab and grab a number slider. Like before, we'll adjust the min and max values. Double-click to type in a value, and connect it to our component. We'll quickly do the same for the other parameters. If we hover over the output, we can see we've created one input condition with the desired sinkage, trim, and heel. We can create multiple conditions to run by supplying a list of values to any one of these parameters. To connect both of our sliders at once, press and hold the Shift key while dragging the wire. We've created two input conditions. Now, let's say we used two values for trim. The resulting output would be 4 conditions, covering all the combinations of our input parameter lists. So, now we have our input conditions and our geometry. We're ready to add our hydrostatics calculator component. Back in the Orca3D tab, under the hydrostatics category, click Hydrostatics Calc and drag that onto your canvas. Then connect the geometry and condition components. Because of our two input conditions, we now have two hydrostatics results. If we attach the output to a panel, we see the names of the hydrostatics conditions associated with each result. If we want to know a specific value, we have to use a hydrostatics parameter extractor. These are located in the hydrostatics extractor category. Here, the dozens of values available from each Orca3D hydrostatics result are grouped into categories. We'll use a volume parameters extractor and a waterline parameters extractor. Just connect them to the hydrostatics calculator component, and then connect to any parameters you'd like to know the values of. Here, we're using the panel to view displacement, wetted surface area, and the waterline length. And as we drag our sliders, we can see the hydrostatics result automatically updating. There's lots more you can do in Grasshopper with Orca3D, including empirical resistance calculations, which we'll cover in depth in a future video. For now, you know the basics of Grasshopper and how to get started with Orca3D. Thanks for watching, and check out the Orca3D channel for more how-to videos. Got more questions? Get more answers with the help resources in the description.